Well, hello and welcome to your 13th Algebra 1 class. I am Mr. Marcus, your favorite summer online math teacher. And today's topic is going to be intercepts. Now, in our previous videos, we talked about functions, and we said that a function is basically an input and an output value where you have to have one output for every input, or cause and effect. We talked in our other video, we talked about graphing functions and how to do that. So if you guys want, you can go review those videos before you take a look at this one. Today we're going to talk about more specifically linear functions. Now usually a linear function, if you have a table, are graphs that are directly or indirectly related to each other. And they're usually graphed, or when you construct their graphs, they usually have a diagonal line that's going upwards, or a diagonal line that's going downwards. Sometimes you'll have a horizontal line, and we'll talk a little bit about that more in detail in our next video lessons. Today, more specifically, we're going to talk about intercepts. We're actually going to talk about how to find intercepts from a graph, how to find intercepts from an equation, and in our next videos, we're actually going to graph using intercepts. Okay? So let's get started. Yes? Now, what is an intercept? Well, by definition, the word intercept is pretty much intersection, when two things cross each other, right? If you talk about football, when you intercept the pass, you catch the other team's pass. But in math, an intercept means where the line of the linear function actually passes through either the x-axis or the y-axis. Now let's review that real quick. Now we have our coordinate plane, and we know that our horizontal line is the x-axis, and our vertical line is the y-axis. We know that this is what we call the origin, which is where both number lines meet, right? Origin. We know that there are four quadrants, 1, 2, 3, and I'm reviewing kind of a little bit of 7th grade pre-algebra, 6th grade pre-algebra, 1, 2, 3, and 4, right? Now we know that all the numbers to the right are positive, all the numbers to the left are negative, all the numbers that go up are positive, and all the numbers that go down are negative, right? So this is pretty much the basis of your coordinate plane. So let's talk about then what our intercepts are. So an intercept is, if we talk about an x and a y intercept to be more exact, is pretty much when the line of the linear function crosses either the x-axis or the y-axis. Okay, so once again, and I'm sorry, again, an x-intercept and a y-intercept is the point in which the line crosses the x-axis or the y-axis. Now we're going to see how we would interpret them in a graph, and I'm going to give you an example. It's a real easy one. Let's say we have 1, 2, 3, and there's a coordinate here, and it's 3 spaces to the right. And we have another coordinate down here. Let's say 1, 2, or actually 1, 2, 3, and 4. Okay? So our x and our y intercepts. Now let's kind of connect the dots together, and we'll have a linear function. Again, the linear function, because it's a diagonal line and it can go up horizontally or down. Now when we talk about the x-intercept, we actually want to know the x-intercept is the number, the specific number in which this line crosses the x-axis. And we know it's right here. So everything is positive. We counted 1, 2, 3 spaces. So we say that our x-intercept equals 3. Because if you notice, it's specifically in positive 3 where the line touches the x-axis. Now if we look at our y-intercept, which is down here, our y-intercept is the point, that specific point in which the line crosses the y-axis. So if we count, we have -1, -2, -3, -4. So our y-intercept is -4 because it's in -4 where the line is touching the vertical axis in this case, or the y-axis, all right? So that's how we do it in a graph, but how do we do it in an equation, okay? So one thing, before we go into the next example, which is how we do it in an equation, I want you to take a look at something real quick. Notice that in the x-intercept, it's 3 because it's specifically in 3 where the graph touches the x-axis. So when we have an x-intercept, we say that y equals 0. And if you look at the y-intercept, right, it touches at -4. And when we have a y-intercept, because it's crossing the y-axis at -4, we say that x equals 0. So whenever we're working with intercepts, if we're looking for an x-intercept, y equals 0. If we're looking for a y-intercept, x equals 0. Now, how or why is that relevant or important? We're actually going to see it in this example, because I want to find my x and y intercepts specifically, and I'm just going to step out of camera just to make sure that everything is working perfectly. I want to find my x and y intercept specifically from this equation. So I'm going to go ahead, I can start with whichever one I want. I'm actually going to go ahead and look for my x-intercept. Now remember, if I'm looking for my x-intercept, we already established that y equals 0. So I'm just going to write that down here just to remind myself that whenever I'm looking for my x-intercept, y equals 0. Now what that means algebraically is that I'm going to rewrite this equation, but instead of writing 4y, I'm actually going to write 4 times 0, because y equals 0. So you're going to say 2x minus 4 times 0 equals 8. So 2x stays the same, I don't do anything to it. And 4 times 0 is 0, so that would be minus 0 equals 8. So what I'm going to do now to solve for x is add 0. And this cancels out, and 2x equals 8. And I divide by 2. And x equals 4. So in this case, my x-intercept equals 4. Okay? Now I'm going to look for my y-intercept. So again, if I'm looking for my y-intercept, and I'm going to write it down here so I can remind myself. If I'm looking for my y-intercept, x equals 0. Which means I'm going to rewrite this equation, but instead of writing 2x, I'm going to write 2 times 0. So I'm going to say 2 times 0 minus 4y equals 8. So basically, 2 times 0 is 0, minus 4y equals 8. I could add 0, and this is going to cancel out, and I bring down the minus sign and the 4y, and of course the 8. Okay, so again, 2 times 0 is 0, I add 0, I bring down the minus sign, I bring down the 4y, 8 plus 0 is 8. I divide by -4, and y equals -2, because these cancel out, which means that my y-intercept, in this case, equals -2. And that's how we do it with an equation. Now I'm going to step out of camera, just make sure that everything in the technology is working properly and that you guys can appreciate the problems a little better. Let me fix the camera just to make sure that you no cutting, and let me zoom in case you guys still have some questions. Okay, so I'm actually going to go ahead and re-explain the problem just in case. All right, so once again, all I did was I actually had to find my x and my y-intercept. So I started with my x-intercept, which means that y equals 0. So that means I rewrite my equation, but instead of writing 4y, I wrote 4 times 0. So 4 times 0 is 0. I bring down the 2x. Minus 0 equals 8. I add 0 on both sides. 8 plus 0 is 8. 2x equals 8. I divide by 2, and x equals 4. So my x-intercept is 4. Now if I want to do the same thing for my y-intercept, remember that x equals 0. So what I do in that case is I multiply 2 times 0, which is 0. I bring down the minus 4y, I bring down the 8. I add 8. I bring down the minus sign. I bring down the 8. My -4y minus 8, I divide by -4, and 8 divided by -4 is -2, which means that my y-intercept equals -2. And I'm actually going to try this problem now, okay? So I'm going to go ahead and erase this. Again, you can pause and rewind the video, make sure that everything is good. I'm actually going to do one more camera check real quick just to make sure that the phone or the camera isn't looping or doing anything it's not supposed to. Everything seems fine. So let's look at this problem. It says 4x plus 2y equals 16. Now I'm going to look for my x-intercept, okay? So if I'm looking for my x-intercept, remember that y equals 0. So that means I'm going to rewrite this equation, but instead of writing 4x plus 2y equals 16, I'm going to say 4x plus, let me actually do it here where I have more space. So 4x plus 2 times 0 equals 16, because if I'm looking for my x-intercept, y equals 0. So 4x, I bring that down. 2 times 0 is 0. So plus 0 equals 16. I subtract 0. And of course, that would be 4x equals 16. I divide by 4. And x equals 4. So my x-intercept is also 4. Now I want to do the same thing with my y-intercept. I'm going to step out of camera just to make sure, and I know I'm getting a little paranoid, but I want to make sure that you guys can see the numbers properly. Now if I want to look for my y-intercept, remember that if I'm looking for my y-intercept, x equals, or I'm sorry, if I'm looking for my y-intercept, x equals 0. So I'm going to rewrite the equation. But instead of writing 4x, now I write 4 times 0. So I'm going to say 4 times 0 plus 2y equals 16. 4 times 0 is 0 plus 2y equals 16. I subtract 0. I want to say that. And this is going to cancel out, and 2y equals 16. And I divide by 2. And y equals 8, which means that my y-intercept is 8. And that's how you find your intercepts, from an equation and from a graph. Now in our next video lesson, we're going to continue with this, but we're going to graph our answers. So guys, stay safe, and we'll see each other soon. Bye-bye.